All right, so what team am I speaking to right now?
Acumentrics.
Acumentrics. Now, what did you guys place this fall in the symposium?
Second place.
Second place, congratulations. How does it feel?
Very
Feels
good.
good.
Feels good?
Yeah.
Feels good? Now, just tell me in a couple sentences, just a brief description of your project.
We were able to take a standardized power distribution unit and modify that to become a network managed power distribution unit to toggle switches and monitor things such as voltage, current, temperature, and humidity, and overall power being drawn from each outlet.
Awesome, so PDU, is that kind of like a power strip?
It's sort of like a power strip in a general case, but deals with a lot higher power
Mm-hmm.
and is able to also be rack mounted and ruggedized eventually.
Cool. So now, where is this project supposed to go? What's the best outcome, if I could ask?
Our best outcome is to have a fully functioning power distribution unit prototype that comes with a web application for full monitoring of metrics and remote toggling of outlets.
Okay, like you say, prototype. Is this going to be like a bunch of wires, or is this thing like
So
more
PCB.
PCB? So it's more formal.
It's going to be formalized and also have the PCB in a separated metal-to-metal contact to help avoid the high power magnetic interference. So it'll help reduce the amount of EMI being
Okay.
generated to avoid the low voltage and high voltage interference
Yeah, basically stop you from getting shocked.
and distort the data being collected.
Okay, cool. Now, while you guys were working on this project, were there any hurdles or problems that you can remember that were specifically difficult to overcome?
I would say for the hardware side, being able to select the appropriate components, because Acumentrics also asked and suggested that we use a list of components that also would be able to deal with 240, not only
Mhm.
120, and also be able to withstand the military grade temperatures. And so in that case, we had to be able to find components that not only complied with the standard for the power to be drawn through them, but also to be drawn to be able to withstand the military grade temperature between -40 and 80 degrees Celsius.
So that's definitely not like the power strip I have under my desk, right?
Definitely
No.
not.
A little bit more rugged. Cool. Now, developing this, you said that was mostly like an electrical hurdle. Were there any computer hurdles?
Yeah, over on the computer side, there was the real-time chart. Originally, we went with a library that was very advanced, but it was a bit difficult to use.
Yeah.
We ended up going with a simpler library,
Mhm.
but that took a few weeks to get up. Also implementing the real-time functionality. At first, we tried using WebSockets. That was a bit too complicated. We ended up using something simpler, Ajax, but that took a few weeks to get going.
Simpler is, not always worse. Sometimes it can be a little bit better,
Yeah.
Now, while you guys were developing this project, were there any habits or skills that you formed that you find best impacted the progression and the success of your project this semester?
Being able to implement and find different techniques for measuring current and being able to find different documents and being able to look and locate in technical documents such as the Hall effect sensor that we used in our prototype, being able to look through different technical documents that
Mhm.
actually list the benefits of one vice the other.
Okay, so basically research. You guys learned how to research a different way. This is different than just peering through a textbook.
Right.
Right now, so you're working with a company, Acumentrics, and this isn't like a professor giving you an assignment, right?
Not at all.
How would it be different?
We have actual deadlines to meet, actual specifications. We're not given something to modify. We were just told to build something, and it's more like you're working at a company than in school, because in school you're just trying to finish an assignment, something.
And
you've
also a
been
lot
given.
more freedom.
Freedom, so it's not so, well defined.
We had
Right.
a lot broader limits and being able to find and research, like example, the Hall effect sensor again.
Yeah,
was
yeah.
one component that we were able to.
A little creativity, a little ingenuity, kind of one of those skills that are good to have when you're being an engineer, right?
Right.
Yeah.
Awesome. So one question I want to finish up with. We're working with a company, we're doing a Capstone project, this ELECOMP Capstone design program. Do you feel like it's helped you get ready for graduation? You guys are all seniors getting ready to graduate and all, so do you feel as if it's helped you, and if so, how?
Definitely. Over on the electrical side, URI doesn't really offer power electronics, so I feel or I would assume they feel they got a lot of power electronics experience from this project. On the computer engineering side, URI offers a web dev class, but it's not required, so a lot of people don't take it. I hadn't taken it before, and I had no web development experience, and so taking this project helped me develop those skills a lot.
Awesome. Well, guys, thank you very much. Congratulations on second place.
Thank you.
Thank you.
Have a good one.